Spice Industry Rapid Test Methods, Near-Infrared Spectroscopy Applications. My name is Karen Whitman, and I will be today's webinar moderator. It is my pleasure that you guys have all joined us today. Before the presentation begins, I do have a couple housekeeping things to go over. The first thing is today's webinar is recorded, and the recording will be available in 1 to 2 days. All questions will be answered at the end of the presentation portion. In order to submit your question, please go to the queue and enter it there. If your question does not get answered during the webinar for some reason, our speakers will reach out to you in the next couple of days with an answer to your question. Now, how to get your question into the queue. So go to the question panel and the go to webinar panel. There's a down at the bottom, just click on questions, and then in the text box, go ahead and write your question and then press send. Then that will put it in the queue for the end of the presentation. It is now my pleasure to introduce you to today's presenters. We will start out with Karen Gerwitz. Karen has 20 years of experience in quality assurance and product testing in the food and consumer products industries. She specializes in delivering instrumentation solutions and is a veteran in implementing customized infrared solutions for both mid-infrared and near-infrared benchtop and inline testing systems. Prior to joining the Eurofins team 2 years ago, Karen held previous positions with Buena Vertes, ConAgra, and Buffalo Filter. Karen is an active member of ASTA, American Spice Trade Association, in the NBB, or the National Biodiesel Board. Karen holds a Bachelor's of Science in Biology from the State University College at Buffalo in conjunction with the University of Georgia. She will be accompanied by Supat Servika. Supat began his career as a laboratory technician at Strasburger & Siegel Incorporated, a commercial food testing laboratory, and became a partner of the company in 1989, then sold the company to Eurofins in 2009. He led Strasburger & Siegel to be a well-known, trusted laboratory specializing in all aspects of spice testing, including microbiology, analytical chemistry, filth and extraneous, and FDA detention-related matters. Joining ASTA in 1997 was the critical step in understanding the spice industry. Supat has been serving as a member of the technical committee since 1998. Supat holds a master's and doctorate from the University of Maryland in College Park, each in food science. Our last presenter for today is Alan Darrier. He is the Director of Analytical Laboratory Services at Wixon Incorporated. Founded in 1907 and based in St. Francis in Milwaukee, Wisconsin, Wixon is a fully integrated meat, food, and beverage ingredient leader, providing flavor technologies, custom ground spices, blended seasonings, protein expertise, food service, and manufacturing, and customer products and packaging. Alan joined Wixon in 1995, overseeing the analytical laboratory. He specializes in identification of volatile and functional chemicals in a wide array of ingredients, along with leading the search and implementation of innovative methodologies and equipment and maximizing efficiencies operating in a supply chain environment. Prior to joining Wixon, Alan held a similar position at Fonarome, located in Paris, focusing on flavors and fragrances. Alan serves as ASTA's Food Safety Committee and chairs the Analytical Methods Subcommittee. Alan has a master's in organic chemistry from the National Academy of Arts and Crafts in Paris. It is now my pleasure to hand over today's webinar to Karen Gerwitz. Thank you.
Thank you very much, Karen. I do have some background noise, so if anybody does not have their phone on mute, if you could put it on mute, hopefully that'll be eliminated. So for today's agenda, I will talk about near-infrared fundamentals, some considerations for a successful near-infrared program, some of the challenges associated with near-infrared, our patented Eurofins QTA technology, areas of application for near-infrared, and then I will pass it on to Supat to talk about primary test methods for spices and the pros and cons associated with those methods, along with the performance and reproducibility of the primary methods, along with QTA's near-infrared methods. Then I will hand it off to Alan, who will talk about his experience using the Eurofins QTA near-infrared system as a rapid test method for spices from a spice producer's perspective. And then we will have the question and answer session. With more than 22,000 employees across more than 225 sites in 39 countries, Eurofins is a leading international group of laboratories providing an unparalleled range of testing and support services to the pharmaceutical, food, environmental, and consumer products industries, and to governments. QTA is a division of Eurofins. We were acquired about 3 years ago, and QTA is an analytical testing service provider, along with a partner that helps producers and processors enhance quality testing capabilities and to overcome existing challenges with innovative testing solutions. We specialize in custom on-site testing solutions utilizing FTIR, or Fourier Transform Infrared technology, offering a fast, easy, plug-and-play testing solution. When I say fast, I mean that a single scan covering many traits can be analyzed in less than 2 minutes. Eurofins' unique QTA system provides data and information to better control processes, improving profitability. By rapidly analyzing a variety of traits, the QTA system delivers results when and where you need them. With QTA, our clients are able to maximize the efficiencies of product streams from beginning to end by analyzing material traits throughout the process, increasing yield and minimizing waste. Here is a snapshot of our laboratories, which are globally operated from the Cincinnati, Ohio area. In the upper left-hand corner in the forefront are some near-infrared instruments. And then in the lower right-hand corner in the forefront are some mid-infrared instruments. So we call this a total solution, which involves wet chemistry capabilities, along with QTA's infrared expertise to give a great solution based on infrared technology. Let's talk about the electromagnetic spectrum, which is the collective term for all known frequencies and their linked wavelengths of known photons. The electromagnetic spectrum of an object is the characteristic distribution of electromagnetic radiation emitted or absorbed by that particular object. This spectrum extends from below the low frequencies used for modern radio communication to gamma radiation at the short wavelength or high frequency end. Visible light wavelength ranges from 390 to 770 nanometers. In near-infrared ranges from 770 to 2,500 nanometers. So for the basic principles of infrared spectrum, the infrared region of the electromagnetic spectrum is light with a longer wavelength and lower frequency than visible light. So when a sample is exposed to a light source, the light is either transmitted through or reflected off of the sample, which creates a spectrum for that particular sample, which can be used to fingerprint against other known samples or a library. Near-infrared can be used for both qualitative and quantitative analysis. Let's focus on quantitative, or the determination of chemical composition or chemical properties. First, calibrations must be created using primary test methods, then collecting spectra via near-infrared, then chemometric modeling to develop the model, Now, using the chemometric model, samples can be analyzed quicker and easier than the traditional or primary method. Again, when I say quicker, I'm saying this whole process can be done in less than 2 minutes. So some of the advantages of near-infrared analysis, obviously the time, less than 2 minutes. It's rapid testing and it's non-destructive. It's easy to operate and maintain. There's little to no sample preparation. And it's virtually a chemical analysis without the need for chemicals or a chemist. You can scan for multiple components in a single analysis. It has great reproducibility, and the analysis can take place in any working environment. The photo on the right-hand side is a typical near-infrared instrument, and on the left is actually a vial of spice, which is how we traditionally or typically would test spices. So where do I begin? With the extensive brand options and different types of infrared systems available, some of the key factors to consider are: what is the optimal instrument and sampling device for my specific application needs? Who will serve as the chemometrician and spectroscopic expert to build and maintain reliable methods? How can I prove performance prior to making such a large capital investment? How do I build a sufficient library of representative samples and good quality primary data to build the models? Who will manage the system and make improvements and adjustments once the system is in place? And lastly, user-friendliness. Ideally, the system should be operable by any plant operator. Here are just some of the examples of the available systems out there, along with the different types, spectral ranges, and applications that you can choose from. So for expertise of algorithm development, remember garbage in, garbage out. You need to select the right reference methods and the right primary laboratory to conduct the initial testing. Then you also need to understand your SEP, or standard error of prediction, that you're starting with. You need to design the sample matrix, which entails knowing your materials, knowing your limitations, and having real or pure samples for the initial development. For an optimal near-infrared system, an intranet-enabled system with a centralized processor and database should be considered. This allows multiple near-infrared instruments to use the same model, regardless of location around the globe. QTA holds several patents in the infrared space. The technology behind infrared is chemometrics. QTA's founder and Chief Technical Officer is Dr. Chang Peng. One of our patents is Chingometrics, which is enabling technology for QTA's unique operational strategy with unique features, such as the ability to successfully share robust calibrations on multiple instruments, overcoming the need for bias adjustment and drift. So here's what the QTA logon system looks like. It's very user-friendly. This portal gives real-time access to data at any time from anywhere. Data can be accessed from home, from your office, on the road, from any mobile device. Certificates of analysis can be generated with a click of a mouse. Data services are available for automatic export to Excel or production control systems or any other data management software. QTA has also developed inline near-infrared methods, which mitigates the need to take samples out of production to test on a benchtop unit. It also allows for better process controls, automation, and real-time trending. Here is a real-time trending view of an inline system. With a user-friendly home screen that you can choose what location or locations you would like to run the scans at, what trait or traits you would like recorded, along with the frequency of scanning you would like tested. The system can be programmed to automatically scan up to 30 times an hour or every 2 minutes. The specific example is from a biodiesel application Here, they're determining what the acid number is over time in the final product, which is B100. So as you can see, it's a great monitoring tool and eliminates the step to take it out of the production and run manually on a benchtop unit. The QTA system is so versatile that we can work with the biodiesel industry to soybean testing. The Soybean Quality Traits, or SQT program, was a collaboration of the United Soybean Board and the American Oil Chemists Society, AOCS, with the goal of creating a system of analytical verification for soybeans. The SQT program sponsors a quarterly round-robin testing program using up to 23 wet chemistry labs and 27 near-infrared systems. This study was based on 16 soybean samples, taken 4 per quarter. The range of near-infrared results, or the blue error bar, is based on data collected from 17 laboratories. The wet chemistry mean, or the green square, is based on data collected from 15 laboratories. The red star, or X, is the QTA result. Using QTA's patented near-infrared system, the result is very close to the wet chemistry mean in each instance. Now I will ask Supat to discuss the next few slides.
Good morning. Here are examples of spice quality traits that are important to spice industry and suitable for NIR analysis. Steam volatile oil, moisture, scoville heat, extractable color, and pickling content. There are well-established procedures in the ASA analytical manual, and these methods are used throughout the industry. For example, ASA method 5.2 for steam volatile oil. Now, many of these methods take a very long time to perform the test. For example, it takes up to 8 hours of distillation for ASA method 5.2, and take up to 16 hours of extraction for ASA method 20.1 for extractable color. With the measurement of this quality trait by NIR, all of these methods can be done in less than 2 minutes. Now let's take a look at how good these methods are. Next, please. One way to measure how repeatable of this method is by looking at the relative standard deviation. Now, the relative standard deviation or coefficient of variation is a measurement of standard deviation over mean expressed in percent. And typically, relative standard deviation of less than 10% is well accepted of having a good repeatability for that method. Now, the number in the table show relative standard deviation calculated from ASTA check sample data over 12 years, from 1997 to 2009. Essentially, it's 48 quarters. The average relative standard deviation for steam volatile oil is 14.5%, well above 10%, and it has not changed. In 2015, for all 4 quarters, the relative standard deviation was averaged at 15.3. Now, the other 4 methods over that 12-year period, all of their relative standard deviation is less than 10%. Next, please. Now, we did a lot of measurement of steam volatile oil of black pepper by the QTA NIR analysis. We did 7 experiments of SVO and moisture. And each of these experiments we did between, including 16 to 20 sample, 16 to 20 time of measurement over several days using 4 different instruments. The average relative standard deviation for SVO was 5.67 compared to 14.5% by Astor method 5.2, almost 3-fold reduction. The average relative standard deviation for moisture was 2.69 compared to 6.6 by Astor method 2.0. It's about 2-fold reduction. Next, please. The reason behind this is the predictive model that created by QTA, the single metric. It takes out the variation between instruments and different days of measurement. And the red line showing the measurement of oleic acid in canola oil using 15 different instruments of 3 samples in duplicate show a huge variation, where the reading by the single metric, the variation was reduced down to almost 0. Okay, next please. Okay, we take a look at this steam volatile oil analysis back for 2015 of the Astor check sample program for all 4 quarters. And for all 4 quarters, the QTA reading shown in blue X is very close to the mean of Astor that shown in the red square. And we can take a look at this again in different formats. Next, please. By looking at the Z-score of those check sample period, the Z-score is used to measure a lab performance against other labs in the same study. Each lab is free to use any method in the study. This practice is used by third-party check sample providers such as Astor, API, and AOSC. The Z-score of within plus minus 2 is acceptable. The Z-score of greater than plus minus 3 is unacceptable. The Z-score of QTA NIR measurement is within plus minus 1 in all 4 quarters. And 2 quarters were very close to 0. The second quarter of the value of minus 0.18 and the 4th quarter of 0.06. Now we can look at this in more details. Next, please. This graph showing the Astor check sample for quarter number 1 of 2005. Of all 39 labs, 38 labs, plus 1 lab of QTA become 39. All labs are performing well. They are, with the exception of 2 labs that have a value of over a Z-score of over 2. And QTA is number 30 and is less than 1. Okay, I'll show you another example of second quarter. Same thing here. All labs are performing well, with the exception of 1 lab have a Z-score greater than minus 2, and the QTA value is very close to 0 again. Next, please. Okay, this table showing the development of QTA predictive model. The very first line is a generic spice model, which is including all kinds of spices. It shows very good linear of R square of 97.6. However, the standard error of prediction is 0.6. Now, when we build new model for each of those spices, from allspice to white pepper, all of them show very good linear of R squared greater than 95. However, the standard error prediction is less than 0.6. most of them are between 0.2 to 0.4. Okay, next please. So when we take it further, refinement from the generic model that including all spices, we took a reading of 769 sample and over a very wide range of steam volatile oil reading of 0 to 20.6. It showed a good linear of R squared of 97.6 of a standard error prediction of 0.6. Now, when we narrow it down to just black pepper, that including ground and whole black pepper, we took the reading of 240 samples, narrowed the range down to 0.4 to 5.5. The linear is still very good at 96.9. However, the standard error of prediction got reduced to 0.35. Now we take it one step further, we just reduce it down to using black pepper, ground black pepper only, and we took the measurement of 52 times with a smaller range of 0.85 to 3.26. The linear is very good, 98.6. However, the SEP got reduced down to 0.15. So this demonstrated that we can build the model to whatever your design objective is. All right, next please. This is an example of our feasibility that is in ongoing study right now. We took 50 samples of data point of a very wide range of Scoville heat unit of 14,000 to 120,000 Scoville heat unit. It shows a very good linear of the R square of 96.4 with the standard error of prediction of 7,500. And again, because the range is very wide, so the standard error of 7,500 is obviously very good for the high end of the reading, is not really good for the low end reading. And this indicating that we need to have several models for different range for Scoville heat. But the takeaway from this is it will work. We just have to refine it to break it down into smaller range so we can get the standard error of prediction smaller. Next, please.
Okay, now I will jump in here. Thank you. I will jump in to talk about the key benefits of QTA. It is a versatile system. It's one device for many grains, materials, and traits. It's a smart system with high-tech analysis without the high-tech costs of operators. It's great for field use. It's quick, easy, non-destructive, and it's rugged. Some of the instruments can be taken right out to the field and test before it's even harvested. We have a centralized network which ensures consistency, remote monitoring, and remote method development. And if desired, a facility with many locations can all be pulling from the same central model. So there's no lab-to-lab bias. Information access, it's real-time from multiple locations, and you can get it anywhere you have an internet connection, including on your mobile device. And it's affordable. There's no capital investment required. It is a fee-based service. So in summary of QTA's offering, at the client site, you'd have the near-infrared device, a computer, and the spectral collection would happen on site along with the sample management. Through the internet, QTA is developing algorithms, offering 24/7, 365 support, monitoring systems to check the instrument, and it's where the servers and the data are stored. So the data is stored. So you have the ability to centrally check instruments, sample spectra, and programming on the client computer, The algorithms are shared over the supply chain for method standardization and data consolidation. And QTA removes all of the algorithm development and maintenance from the client. So you can focus on other things, and QTA does that work. So the total solution for spices. It's a simple ongoing monthly fee for service-based, based on sample volume, connection to the QTA cloud and QTA algorithms, ongoing data monitoring, customized algorithm development, and annual updating and validation. So overall, in a nutshell, we start with a feasibility study, which we ask our clients to complete a wish list. What materials and what traits are they interested in? Then we prioritize the top 3 or 4. We ask for 30 samples along with the primary data for those traits of interest. Then we issue a feasibility study. Then we work on the development phase, and then we do the validation phase. And at that point, the system is up and running, and you can easily access your results, and the testing scan time only takes 2 minutes. Now I will ask Alan to discuss his experience as a spice processor using the QTA system.
Good morning, everybody. My name is Alan Darye, and I'm one of the users. I was approached about 3 years ago by my friend Supat, and it was really great timing because our company had moved to a what I would call a supply chain environment type of business. What it means, and we're pretty not the only one in that kind of scheme, which is we want to minimize inventory of any ingredient, and in this case spices, to a minimum to avoid financial burden too much. What it means really is that we get more deliveries per cycle, let's say per month, potentially with small volumes, and everybody wants the answer yesterday. On the other hand, we don't have extensive resources, and it's pretty the case for everybody. We cannot just multiply the amount of workstations, the amount of personnel, just to absorb the workload every single day. Also, over the years, at Wixed, we got into new pieces of business. And initially, it was like any kind of spice. Then suddenly we get natural spices for natural application, meaning that some of the micro-reduction options available had to be a little bit more specific than whatever, meaning that we basically multiply the amount of SKUs or part numbers that we would have to handle every single day, meaning that you have to multiply the amount of testing because you get a lot more deliveries. Next, please. The implication is like, as time goes by, we have less time available to release the material. We have a lot more samples to process every day. And as Supat explained before, the critical testing methods such as steam distillation to evaluate VO, tool ash, Scoville heat unit for capsicum, and some of the others, that are critical to evaluate the quantity of the supply, well, those methods take time. VO, basically at least 7 hours you're going to have to wait. Ash, about 5 hours. Some of the others are shorter, but they cannot be done at one time. Not to mention the fact that, well, you get equipment, glassware to clean, you have to use hazardous material, and the big factor is that you have to have trained employees for each of those conventional techniques. Given the fact that sometimes it's hard to maintain your employee base, you kind of quickly face the situation where a trained employee could leave your company and then you have to start all over again, which is, needless to say, a little bit irritating in the end. Next, please. So what were our options when it became clear that it would be difficult to test both the supply that we were getting and do it quick? Either we had to go to a spot checking only, and that kind of scared us a lot. We could have shifted to approved supplies based on indication coming from a COA, from a vendor, rather than just do actual verification, or develop an alternate and rapid testing method. And that's when near-infrared presented itself as a potential way of getting what we wanted, which was to have a evidence that the quality of the supply was there, but also being able to do that extremely rapidly. Next, please. We've been using the QTA near-infrared technology for over 3 years now. And we started with trying the equipment. I was not sold initially on the fact that it would be able to measure what I wanted. But we were willing to try, and we were willing to find something, a method that would allow us to get the result we needed, to get the confidence that the supply we're getting was within our specification without going through those erratic solutions such as spot checking or just taking numbers out of the COA, because we definitely wanted to be in charge of making sure that the quality of the supply was there. The near-infrared, as Supat has mentioned, and Karen as well, is extremely simple to use. I've never seen anything that simple. And without doing a joke, I would say that if you are capable of filling a test tube, you're about 95% done in getting the result. A great advantage is that you can get multiple test results at once. They keep our predecessors saying about less than 2 minutes. Our experience says, well, it's more like less than a minute. And we get volatile oil, total ash, loss on drying, moisture, and we're currently helping develop the foveal heat model. Coming along pretty nicely, but it takes time. Near-infrared technology requires to run a lot of samples, and the more samples you run, the better results are going to become. Next, please. As I was saying, multiple tests in less than a minute compared to several hours waiting. The people in the supply chain at Wixon are ecstatic when it comes to that, because we reduce the amount of time it takes to release delivery tremendously. Sample prep, equipment setup, time-consuming glassware, almost nothing done left for us. Hazardous chemical handling, virtually none. As we accumulate data, the system becomes more reliable. And next. Here are some of the recent results that we are getting using the QTA technology. And we use ASTA samples. Wixon is part of ASTA, and we definitely participate in the search program just to make sure that whatever testing method we're using, we're in line with everybody in the industry. So we are using near-infrared technology, and I just published on that page the result for 2016 second and third quarter. And you have the ASTA average VO results. It's based on 2 readings. And the what I call lab SVO, which is the conventional steam distillation method. And on the far right, what the near-infrared gave us. With such results, which are obviously extremely close to the ASTA average result, we are extremely confident that our method and the QTA method we're using is keeping us in that safe zone where we can both quickly assess the quality of a delivery and still be safe and confident that the result is what we needed to get to make sure that we can make a pass-fail decision on the delivery. Now, what happens when a result is outside the specification, you would say? And that's pretty simple. We go, if the results are bad, we go to the conventional method, because when it comes to a dispute between the vendor and the seller, you need to be using the exact same method. Near-infrared is, I would say, the spice industry still in the infancy of it. And but as time goes by and as we accumulate data to prove that such technology give as good, if not better, result with a dramatic decrease in the amount of time spent doing the testing, I think we're in good shape. And definitely at Wixon, we see a tremendous benefit of using that technology. We can test every single delivery. I'm not even mentioning being able to evaluate our aging inventory, which was presenting some challenges in the past because it was just adding more samples to the conventional map testing on it. Now it's a breeze, and all the technicians using the equipment love it, and they can't even start to believe that one day that technology would not be working. That would be dramatic for everybody, and it would be dramatic for us, because going back to time-consuming methods is probably not going to be a good idea. As time goes by, our business is evolving. We need results faster and faster all the time. I think that less than a minute is probably good enough for many years. Next, please. So in short, we use the QTA near-infrared technology as a screening tool to allow for a fast turnaround time, but we also use it because we know that we can rely on a result. No spot checking and not copy-paste from a COA, which is probably the worst method possible. We use spice samples testing in duplicate, and we average the result if they fall within a reasonable difference. The technology offers us several subcategories which allow for a more accurate type of result and standard deviation compared to a model that would cover about everything. Different spices have different properties, and the behavior with near-infrared could be slightly different. We're currently testing a red pepper model for Scoville heat unit. Whoever does the analysis by HPLC knows that it takes a lot of time. We're down to less than a minute. Hard to beat. Of course, we verify failing results using conventional techniques, and what we can say is that since we've been using QTA near-infrared, is that the number of verifications that we have to do monthly is less than 1, which means that, and we expect that number to keep going down because the system we use is getting more accurate, more robust every single day by running more and more sample and using Eurofins expertise to look at the models, adjust the response based on the ranges that we see, because the model needs to be getting some teaching or experience. And from there, every single day we get a better system. So resorting to conventional method the need for it will go down. We know that. So all in all, we're extremely happy with the system. We're also extremely happy with the service. The 24/7, 365-day online support is real. I can vouch for that. It's extremely helpful to know that we don't really have to do much about the equipment. It is calibrated automatically. We have online support. Way to go, and we didn't have to spend the $75,000 to buy a near-infrared spectrophotometer. So that was also a big plus in that type of service. Next, I believe I'm done.
Yes,
Yep.
Thank you very much. So at this point, we can open the floor for Karen to lead the question and answer session.
Thank you, Karen and Supat and Alan, for a great presentation. As Karen said, we are now in the Q&A session of our webinar today. So if you have any questions, please go ahead and put those in the queue. We do have some questions already, so here's our first question. How do you verify that the response that you get from QTA are in line with reality?
Okay. Well,
I'm going to take that one.
Go ahead. Go ahead, Ellen.
We do it two ways. The first one is that we use the quarterly ASTA check sample program, and we use black pepper and whole oregano to measure the VO, moisture, and ash. And when the capsicum model is going to be fully operational, we will also use that for Scoville heat unit measurement. So that's helpful because we keep in line, and we use that to teach the model and eventually tweak it. Now, the other thing that we do is that when we get the results from QTA, we just don't believe it's falling from the sky like God's will. If it's not accurate or if it's failing a result, we do not just take that result and say, oh, the delivery is rejected. We resort to verification using conventional methods, and so far, we haven't come across a situation where there were a big difference that would justify the fact that we could not use the near-infrared result as a primary pass-fail decision. But because we're prudent, whenever we get a failing result, we do go to verification. That's standard protocol. But we're pretty confident that we will not need to resort to that time-consuming verification.
Okay, thank you, Alan. The next question is the data combined for all users of all NIR instruments, or is analysis built off of samples per customer?
I can take that one. We do have master models, but anytime a new client is interested in pursuing the services, we do an individual feasibility study for the specific materials and traits that they're interested in. And that data always stays confidential with that client, and we make sure that our model is within that range. So we have a master model, but then we tailor individual models for specific client needs.
Thank you. There's actually a follow-up question to the last question that you just answered, Karen, and that is, what if a particular customer has bad product? Will it bring down the results of other clients?
No, it should not, and that is in the patented chemometric modeling, which makes it's the chemometrics, but the modeling is very robust, and the models are trained to recognize things such as outliers. So likely you'd get information that said outlier because it didn't fit within the model, and that would trigger someone to double check the results.
Okay, thank you, Karen. Our next question is, how long before the Scoville heat model will be available?
That can be ready as soon as we have more data put into the model. As Supat had mentioned, it's a very wide model, and so the standard error prediction, if you're at the high end of Scoville heat, it's an acceptable model. But when you have results that are at the lower end, that standard error prediction is relative. So it's very big in comparison to the lower end numbers. So what we really need to do is maybe break that model up into 2 or 3 sections to have for the different parts of the full range. So that can happen literally as soon as we get maybe 20 to 30 more samples of a wide range of results, and I think specifically at the lower end, and that can be ready. So based on when we get the requests and samples in, it could happen as shortly as within 2 weeks.
Great, thank you, Karen. The next question is, how quickly can my company be set up and running with the near-infrared system with QTA?
Okay, that again is variable. It is dependent on the process and how quickly we get samples in. It also depends on if it's a very straightforward SVO moisture ash is the request, and it's very similar materials to what we already have in the model, then that we could get somebody up and running as long as they had samples to validate their specific material type. We could have that up and running within 2 weeks. If it's more complicated and they have other things on the list, it could take potentially longer, but it can happen pretty quickly.
Okay, thank you. Our last question for today is the following. Is there a timeline for ASTA to accept near-infrared as an approved test method for steam volatile oil?
Well, this is Alan. Being chair of the method subcommittee, I'm guessing that question is for me. I have to be extremely clear about the attitude of ASTA. ASTA is not out there to promote a specific company product. And in that case, Eurofins QTA technology would fall into that category. That being said, near-infrared is proving to be extremely efficient to be a workable alternative to methods that have been used in the industry for many, many decades. So it could be at some point that there would be feasibility testing, but I would encourage people to kind of keep an eye on, if they use the technology, to make sure that the result they get are in line with what ASTA members are doing using conventional methods, and take the benefits of getting fast results rather than just say, oh, I'm using an official method that would have some kind of a stamp by an organization like ASTA. If the technology, near-infrared technology, which is available already to buy by everybody, the problem is developing the models. Eurofins did the development, so that's helpful. I'm guessing that if I had a near-infrared instrument, I could develop the model if I had the right people to be able to do the mathematics behind it, and if I had 5 to 6, 10 years of working, accumulating data, maybe I would get my own solution. I don't have that. I don't have the resources, so I'm just using the tool that Eurofins is providing, and I make sure that the results that we get are in line with the industry results, and as far as I'm concerned, I'm happy with that.
Thank you, Alan. That concludes our webinar for today. Thank you, Alan and Supant and Karen, for your time and your knowledge on infrared and the spice industry. Thank you for all our attendees for your time today. I hope everyone has a great week. Thank you.
Thank you.